Before there was Linux, before there was Windows, before operating system was even a phrase ordinary people understood, there was CP/M. For a genuine stretch of the late 1970s and early 1980s, CP/M wasn't a niche, hobbyist alternative to some larger, more dominant platform. It was the platform. It ran on more different machines from more different manufacturers than any other operating system on Earth. And then, within the span of about 5 years, it was gone. Not through some dramatic technical failure, but through a sequence of business decisions, missed opportunities, and one enormously consequential meeting that ended with the company controlling CP/M on the outside of the deal that would define the next 2 decades of computing. Most people who've never studied early computing history assume the operating system market has always looked roughly the way it looks today. A small handful of dominant platforms, entrenched for decades, each with an obvious and inevitable seeming claim to its position. CP/M's story is a genuinely useful corrective to that assumption. There was a moment, not that long ago in the broader arc of computing history, when the dominant operating system of the entire industry was built by a small, independent company licensed on genuinely open commercial terms to any hardware manufacturer willing to pay for it, and then lost that position within the span of a single decade. Not to a technically superior product, but to a company that out-negotiated it. And then, when the original loser tried to fight back, allegedly sabotage that fight through means a court would later find serious enough to warrant a settlement worth more than $500 million. This is the story of what CP/M actually was, why it mattered so much more than most people today realize, and how it ended up buried, not forgotten by history entirely, since serious computing historians still study it closely, but buried in the much more literal sense that Microsoft, the company that displaced it, spent years actively working to make sure it stayed buried, long after the original commercial battle had already been decided. Let's start with what CP/M actually was, because understanding the genuine scale of its dominance is essential to understanding just how significant its eventual displacement really turned out to be. CP/M stands for Control Program for Microcomputers, and it was created by Gary Kildall, a computer scientist who'd been working as a consultant for Intel in the early 1970s. Kildall had been developing software to help program Intel's early microprocessors, and in the process, he built something considerably more ambitious than a one-off utility, a genuine general-purpose operating system, capable of running on a wide range of different hardware built around Intel's 8080 processor and its successors, rather than being locked to one single specific machine the way a lot of early computing software was. It's worth understanding Kildall's own background a bit further, since it shaped exactly the kind of operating system he ended up building. Kildall held a PhD in computer science from the University of Washington and combined genuine academic rigor with hands-on practical experience, working directly with Intel's hardware engineering teams, a combination that gave him both the theoretical grounding to think carefully about operating system design as a general problem and the practical, hardware-level familiarity to actually build, something that worked reliably on real physical microprocessors rather than remaining a purely academic exercise. That dual background is a big part of why CP/M ended up being genuinely well-engineered rather than simply an early, rough proof of concept that happened to arrive first. That last point is genuinely the key to understanding why CP/M became as dominant as it did. In the mid to late 1970s, the microcomputer industry was a genuine wild west of incompatible hardware. Dozens of different manufacturers building machines with different processors, different memory layouts, different disk drives, each one effectively requiring its own custom software, written specifically for that one machine. CP/M solved a genuinely difficult, genuinely valuable problem. It provided a standardized software layer that let programs written for CP/M run across this fragmented landscape of different hardware, provided the manufacturer had done the comparatively modest work of adapting CP/M's hardware-specific portion, what Kildall called the BIOS, or Basic Input-Output System, a term that would go on to have a long life well beyond CP/M itself, to their specific machine. That architecture, separating the hardware-specific portion from the rest of the operating system, is exactly the kind of foundational engineering decision that made CP/M genuinely reusable across an enormous range of different computers, rather than being a one-off solution for a single manufacturer. By the time CP/M reached its peak, it was licensed and running on an estimated 3,000 different hardware models, an almost absurd degree of market penetration for a single piece of software during an era when the entire personal computing industry was still figuring out its most basic conventions. Digital Research, the company Kildall and his wife Dorothy co-founded to commercialize CP/M, was generating somewhere between $4.5 and $5.4 million in annual revenue by 1980, a genuinely substantial business for the era, built almost entirely on licensing this one, foundational piece of software to an enormous and rapidly growing ecosystem of hardware manufacturers, It's worth pausing on just how much of modern computing's basic vocabulary and structure actually traces back to CPEM, since a lot of it has simply become invisible background assumption at this point, the way genuinely foundational technology often does. The concept of a hierarchical file system with drive letters, the basic command line interface conventions that persisted through DOS and into early Windows, even specific commands and their syntax. A meaningful amount of that lineage traces directly back to decisions Kildall made while building CP/M in the mid-1970s. When later operating systems, including Microsoft's own DOS, adopted similar conventions, they weren't inventing those ideas from scratch. They were building on top of a foundation. CP/M had already established as the de facto standard for how a personal computer's operating system should actually behave. So if CP/M was this dominant, this foundational, and this commercially successful, how did it end up losing the single most consequential deal in the entire history of personal computing? The contract to supply the operating system for the original IBM PC? We've covered the specific mechanics of that failed negotiation in detail elsewhere, but the short version matters here too, because it's the direct hinge point on which CP/M's entire trajectory turned. In 1980, IBM approached Digital Research about licensing CP/M for its new personal computer project. The negotiation broke down over a genuine substantive business disagreement. IBM wanted to purchase the rights to CP/M outright for a flat fee, while Kildall and Digital Research wanted to license it on an ongoing royalty basis, consistent with agreements Digital Research had already made with its existing customers. There was also a real technical mismatch. IBM's timeline called for a 16-bit operating system, while CP/M at that point was still built around 8-bit architecture, and Digital Research couldn't commit to the accelerated development timeline IBM was demanding. When those negotiations stalled, IBM turned instead to Microsoft, which acquired the rights to a CP/M-compatible operating system called QDOS from Seattle Computer Products, and relicensed it to IBM, a piece of software that would eventually ship as PC-DOS, and in Microsoft's own separately retained licensing rights as MS-DOS. That single deal, Microsoft retaining broad rights to license DOS to any manufacturer building IBM-compatible machines, not just IBM itself, is the specific structural decision that mattered more than almost anything else in this entire story. As the IBM PC platform exploded in popularity throughout the early to mid-1980s, and other manufacturers rushed to build their own IBM-compatible machines, Microsoft was positioned to collect a licensing fee on nearly every single one of them. Digital Research, despite having built the operating system that CP/M-compatible machines had already been running for years, watched an entire new generation of hardware standardize around a different Microsoft-controlled operating system instead. But here's where the story genuinely doesn't end with that one lost deal, and where the buried part of this video's title actually starts to matter. Digital Research didn't simply fold up and disappear the moment DOS won the IBM contract. Kildall and his company kept fighting for market share for years afterward, through several genuinely serious, technically competitive attempts to reclaim the ground CP/M had lost. And Microsoft, according to extensive documentation that later surfaced through litigation and industry reporting, worked actively and deliberately to make sure those attempts failed. The most direct of these attempts was a product called DR-DOS, released by Digital Research in 1988. DR-DOS was genuinely significant. It was a functionally compatible alternative to Microsoft's own MS-DOS, meaning it could run the same software, but it offered meaningful technical improvements. Microsoft's own DOS lacked at the time better memory management, built-in disk compression, and other features that gave DR-DOS a genuine, substantive, competitive edge over Microsoft's equivalent product for a real stretch of the late 1980s and early 1990s. This wasn't a token, symbolic competitor. DR-DOS achieved genuine, measurable market share, and by some industry estimates was outselling Microsoft's own DOS in certain specific market segments during its strongest years. Microsoft's response to that genuine competitive threat is where this story moves from ordinary business rivalry into something considerably more deliberate. Internal Microsoft engineering notes and code, which later surfaced during litigation, revealed that Microsoft had built specific code into early versions of Windows 3.1 designed to detect whether the underlying operating system was DR-DOS rather than Microsoft's own MS-DOS. When Windows detected DR-DOS, it would display a deliberately alarming, spurious error message, warning the user that an unknown or incompatible version of DOS had been detected and suggesting that instability or serious problems might result from continuing, despite the fact that DR-DOS in reality ran Windows perfectly well, with no genuine technical incompatibility whatsoever. This wasn't a case of Microsoft genuinely encountering compatibility problems and warning users in good faith. It was manufactured, deliberately false code, specifically engineered to scare ordinary users away from a competitor's product they had already chosen to purchase and install, through a fabricated warning with no legitimate technical basis behind it. It's worth understanding exactly how insidious this specific tactic actually was from an ordinary user's perspective, since the framing matters to appreciating just how deliberately deceptive it was. An ordinary computer user in the early 1990s, seeing an official-looking warning message from Windows itself claiming their operating system might be unknown or potentially unstable, had no realistic way to know that warning was entirely fabricated, with no genuine technical basis whatsoever. That user would reasonably conclude their choice of DR-DOS had been a mistake, and many likely switched back to Microsoft's own MS-DOS as a direct result, not because DR-DOS was actually inferior or genuinely incompatible, but because Microsoft's own competing product had been specifically engineered to lie to them about it. This specific practice became known both within Microsoft internally and later in the broader tech press by a genuinely blunt internal shorthand, AARD code, named after the Microsoft engineer Aaron Reynolds, whose initials appeared in some of the relevant code comments. The AARD code checks weren't a one-off accident or an overzealous engineer acting alone. The practice was documented across multiple Windows releases, and its existence became a central piece of evidence in subsequent legal battles over Microsoft's competitive conduct during this exact period. Digital Research, and later Novell, which acquired Digital Research and its DR-DOS product line in 1991, eventually pursued antitrust litigation against Microsoft specifically over this pattern of conduct, the AARD code, along with other allegedly anti-competitive practices Microsoft had used to undermine DR-DOS's genuine technical competitiveness. That litigation dragged on for years, and Microsoft ultimately settled with Novell in 2011 for an amount reported at $536 million, a figure that, while never publicly confirmed as an admission of specific wrongdoing, represented a genuinely enormous settlement, reflecting just how seriously both sides ultimately took the underlying claims after roughly 2 decades of legal wrangling over exactly what had actually happened to DR-DOS's competitive prospects during its strongest years. It's worth appreciating just how long that legal process actually took, since the sheer duration itself is part of the story. 2 decades between the alleged conduct and its final resolution meant that Digital Research itself no longer existed as an independent company. By the time meaningful compensation was actually paid out, Gary Kildall himself had been dead for well over a decade, and the specific market conditions that had made DR-DOS a genuine commercial threat to Microsoft in the late 1980s and early 1990s had long since been overtaken by entirely different competitive dynamics in the broader computing industry. Justice, in this specific case, arrived, but it arrived so many years after the actual harm occurred that it functioned more as a historical reckoning than as any kind of meaningful correction to the actual market outcome the conduct had originally produced. It's worth sitting with the actual mechanism of that specific tactic, because it represents something genuinely different from ordinary. Legitimate competitive behavior between rival companies. A company building a genuinely better product, undercutting a rival on price, or outmarketing a competitor through legitimate means is simply how competitive markets are supposed to function. Deliberately engineering your own software to display a fabricated, false warning specifically designed to frighten ordinary customers away from a competitor's product they'd already purchased based on no actual technical problem whatsoever is a meaningfully different category of conduct, using Microsoft's dominant position in one market, Windows, as a lever to undermine a competitor in an adjacent market, MS-DOS compatible operating systems, through manufactured false information rather than genuine product superiority. Digital Research itself didn't survive as an independent company much longer after this period. Novell acquired Digital Research in 1991, absorbing DR-DOS and Digital Research's other products into its own portfolio. Novell, in turn, eventually sold the DR-DOS product line onward to Caldera in 1996, and it was Caldera that ultimately pursued the antitrust litigation against Microsoft through to its eventual settlement, years after Digital Research itself had ceased to exist as an independent entity, and years after Gary Kildall himself had passed away in 1994, following a fall at a Monterey, California bar, never having lived to see the eventual legal vindication, however partial, of claims about how his company's flagship product had actually been undermined. There's a broader, genuinely important point worth drawing out from this specific history, and it's exactly the kind of through line this channel keeps returning to across different eras of Microsoft's competitive conduct. The AARD code episode isn't simply an isolated one-off historical footnote. It's an early, formative example of a pattern that would recur in different specific forms across decades of Microsoft's subsequent history, using Windows' dominant market position as a lever against competitors in adjacent markets, sometimes through legitimate competitive pressure, and sometimes, as the DR-DOS litigation specifically alleged and Microsoft's eventual settlement at least implicitly acknowledged, through conduct that crossed well past the line of fair competition into deliberate manufactured deception aimed directly at ordinary end users. It's worth explicitly connecting this specific 1990s episode to the broader anti-Linux campaign this channel has covered in other videos, because the underlying pattern is genuinely similar, even though the specific target and specific decade were different. Joachim Kempen's documented anti-Linux pressure campaign against OEMs in the early 2000s and the AARD Code's deliberate sabotage of DR-DOS a decade earlier both represent the same basic strategic instinct. Rather than relying purely on Windows' genuine technical merits to win in open competition, Microsoft's institutional playbook, across multiple different eras and multiple different competitive threats, repeatedly included using its dominant market position to actively undermine specific competing products through means that went beyond ordinary legitimate competitive pressure. Whether that meant fabricated error messages aimed at ordinary DR-DOS users in the early 1990s, or quiet, deliberately obscured pricing pressure aimed at OEMs considering Linux a decade later. So where does CP/M's actual technical and historical legacy sit today, now that both the operating system itself and the company that built it have been gone for decades? This is genuinely worth understanding, because CP/M's influence didn't simply vanish the moment digital research stopped existing as an independent company. It persisted, in less visible but genuinely traceable ways, through the broader lineage of personal computing operating systems that followed it. The most direct technical lineage runs through DOS itself. Tim Patterson, the programmer who wrote QDOS at Seattle Computer Products, the software Microsoft acquired in relicence to IBM, built his operating system with explicit reference to CP/M's own published documentation, specifically designed to be functionally similar enough that CP/M software could be relatively easily adapted to run on it. That means DOS, and by extension the earliest versions of Windows, which were themselves built on top of DOS, carried forward a genuine direct technical and conceptual lineage from CP/M, even as the company that had actually built CP/M was being systematically outcompeted and, according to the AARD Code litigation, actively undermined by the very company benefiting from that borrowed foundation. There's also a more philosophical, less directly technical lineage worth drawing out, one that connects CP/M's actual history to the broader open source movement this channel covers regularly, even though CP/M itself long predates Linux and was never an open source project in the modern sense. CP/M's core commercial insight that a standardized portable operating system layer could bring order and interoperability to an otherwise fragmented landscape of incompatible hardware is conceptually similar to the same basic value proposition Linux would offer, decades later, to the server and cloud computing world. A single portable operating system layer running across an enormous, otherwise fragmented range of underlying hardware. CP/M pursued that value proposition through a proprietary licensed commercial model. Linux pursued the same basic underlying value proposition through an open, community-governed model instead. Different business philosophies, entirely different eras, but a genuinely similar underlying engineering insight about what actually makes an operating system valuable to a fragmented hardware ecosystem. It's also worth noting that Gary Kildall's broader technical legacy extends well beyond CP/M itself in ways that don't always get proper credit in the more simplified retellings of this story. Kildall was involved in early CD-ROM technology development, was a co-host of a PBS television program about computing called Computer Chronicles for years, and continued working on operating system technology through Digital Research's later products, including GM, a graphical user interface digital research developed as a genuine competitor to early versions of Windows itself, one that Apple, at the time, considered similar enough to its own Macintosh interface that it pursued legal action specifically targeting GEM's visual similarities, forcing Digital Research to significantly alter the product's appearance in a settlement of its own, adding yet another layer of legal conflict to Digital Research's difficult decade. That GEM dispute is worth sitting with for a moment, because it means Digital Research, across a roughly 10-year stretch, found itself fighting genuinely serious legal and competitive battles on two entirely separate fronts simultaneously, defending GEM against Apple's visual similarity claims on one side, while separately trying to compete against Microsoft's DOS and later Windows on the other. That's an extraordinary amount of sustained legal and competitive pressure for a single company to absorb across a single decade. And it goes a long way toward explaining why Digital Research, despite genuinely capable engineering and genuinely competitive products across multiple categories, was never able to fully recover the dominant market position it had held before the original 1980 IBM negotiation fell apart. Kildall's own personal story ended tragically and somewhat obscurely, a fact that itself contributes to how thoroughly his broader legacy has faded from popular memory compared to figures like Gates or Torvalds. He died in 1994, following a fall at a Monterey, California bar, under circumstances that remained murky enough that his own contribution to computing history has often been overshadowed by exactly the kind of mythologized, oversimplified retelling of the 1980 IBM meeting that later research has worked to correct. A man whose technical decisions still echo through the basic structure of every modern operating system, in ways most users never think about, died largely out of the public spotlight his own foundational work arguably deserved. So let's actually answer the question sitting in this video's title directly. Was CP/M genuinely buried by Microsoft in the more deliberate, active sense that word implies, rather than simply outcompeted through ordinary market forces? The honest answer, based on the documented historical record, is both at different points in the actual timeline. The original 1980 IBM deal that displaced CP/M from its dominant position was primarily the product of a genuine, substantive business disagreement over licensing terms, combined with a real technical timeline mismatch, not, contrary to the popular mythologized version of that specific story, primarily the product of Gary Kildall's own recklessness or absence. But what happened afterward, specifically Digital Research's genuine, technically, competitive attempt to reclaim market share through DR-DOS in the late 1980s, was met with documented deliberate sabotage in the form of the AARD code, a pattern of conduct serious enough that it eventually resulted in a settlement north of $500 million, decades after the fact, once the relevant evidence had finally worked its way through the legal system. That's a genuinely important distinction to hold on to, because it means the popular, simplified version of this entire story. Microsoft simply built a better product and fairly won the market. Captures at most the first act of a much longer, more complicated history. CP/M's initial loss of the IBM contract was a real, if unfortunate, business outcome, arrived at through legitimate, if ultimately consequential, negotiating positions on both sides. What happened to DR-DOS a decade later when Digital Research made a genuine, technically serious attempt to compete again was something categorically different, a documented pattern of deliberate technical sabotage, aimed specifically at making ordinary users afraid of a competitor's product through manufactured false information, rather than allowing that competition to play out on the actual technical merits of the two products. It's worth closing on why this specific distinction between fair competition and manufactured deception actually matters beyond the historical record itself. Markets function properly, and consumers actually benefit from competition only when rival products are genuinely allowed to compete on their real merits, with users making informed decisions based on accurate information about what those products actually do. The AARD code specifically corrupted that basic mechanism at its root. It didn't make Windows genuinely better, or DR-DOS genuinely worse. It simply lied to users about a technical reality that didn't exist, removing their ability to make an accurate, informed choice at exactly the moment that choice mattered most. That's the specific harm this kind of conduct causes, separate from whatever legal penalty eventually followed decades later. And it's exactly the kind of harm that's easy to lose sight of when a story this old gets compressed into a simple Microsoft won, Digital Research lost summary. I want to know whether this is a piece of computing history you'd already encountered before, or whether the AARD code and the DR-DOS litigation specifically were new information to you. Given how directly this connects to the broader pattern of Microsoft's competitive conduct across multiple different decades, Kempin's anti-Linux campaign, the AARD code against DR-DOS, the original antitrust case itself, do you see this as a consistent, repeating institutional pattern? Or do you think each of these episodes deserves to be understood as a genuinely separate, unrelated event? Tell me in the comments. I think tracing these connections across decades is exactly the kind of history that gets lost when each individual episode only gets covered in isolation. If you want more grounded coverage of the real, documented history behind the operating systems and companies that shape the industry we all still use today, subscribe, hit the bell so you don't miss the next one, and I'll see you in the next video.